everyone. So we're here ready to start talking about the electric force. And the first fundamental thing to know about the electric force is that it is an example of a long-range force, and that is in contrast with contact forces. So there are two basic categories of force. Those that require the immediate contact of two objects that are interacting. So, so far in most of the mechanical examples we've been talking about, things have been connected to one another, or they've been colliding, or things like that. And so, in all those examples, we're talking about the objects actually touching one another. An example to the contrary is gravity. So gravity and weight are both examples of forces that do not require immediate contact, and those would be classified as long range. So the electric force is an example of that nature. There's also a third example that we'll touch on this term a little bit, and that's magnetism. The reason I put it first on this slide is really because it's the one we kind of experience as kids first, right? It's, even though we all feel gravity, it's so ubiquitous that we don't even think about it. So usually, our experiences with little magnets, and we play with them as kids, and they almost have this magical quality to them where you have one magnet and you can push it or pull it or different things. You can have it, on the bottom of the tabletop and it's moving something on the top. All these things kind of are all related to the fact that it acts over a long range. And what I mean by long range is not necessarily long, but just the fact that the two things don't actually have to physically touch one another. Now, physicists have kind of had a love-hate relationship with this idea. Newton, when he originally invented or discovered the law of gravity, recognized that also was acting over a long range, and he hated it. He thought it was an occultish type behavior, but the reality is the math just worked. And so he basically just threw his hands in the air and said, I don't really understand what gravity is, but I know how to model it. And so that is where it stood. Now, when Faraday and others started to investigate the electric force and its connection with magnetism, Faraday introduced the idea of an electric field. And the field actually acts as an intermediate concept between the source of the electric force and the thing that experiences the electric force. And there's something in the middle, almost like a fluid or something like that. And so Faraday introduced this idea in order to understand some of the more complicated phenomena that he was investigating, and we'll talk about later. And so that almost solves the issue in that we have the idea now is that we have a source that interacts with the field that's in the middle. The field then transmits the influence to the observer. And so Faraday is the one who kind of divided this idea into, or introduced the idea of a field. And by doing that unintentionally, basically he created a situation in which the field was this new concept, and therefore physicists were able to infuse what was necessary in order to explain the phenomena that they were witnessing in all their experiments and things like that. What that did basically was unshackled the field idea from Newtonian mechanics, from that foundation. And basically what happened was that opened the doorway for the concept of relativity, because the electromagnetic force, in order to explain it in all its fullness, requires relativity, special relativity. And Einstein is the one who kind of brought that all to a culmination. And in a strange way, that concept of relativity feeds back and shows and exposes the weaknesses of Newtonian mechanics. So it's kind of an interesting little story how this all fits together. But before we get into all that detail, let's talk about the electric force in a little bit more detail.